In the eastern reaches of the Tibetan Plateau lies the planet's deepest canyon, a gorge where a mighty river plunges nearly 2,000 meters over a stretch of just 50 kilometers. It is here, in one of the most punishing and remote landscapes on Earth, that China has embarked on an engineering undertaking of almost unimaginable scale. A hydropower complex designed to generate roughly 3 times the output of the Three Gorges Dam. Where Three Gorges produces about 22.5 gigawatts, this new project at Medog is targeting somewhere near 60 gigawatts. Nothing of this magnitude has ever been attempted before, and the price tag reflects that ambition, with estimates placing the total cost around $167 billion. Ground was broken in July of 2025, with completion targeted for 2033. Yet even as construction proceeds, downstream nations are watching closely, because this same river sustains roughly 300 million people once it crosses borders, transforming into the Brahmaputra in India, and later the Jamuna in Bangladesh. China sits at the headwaters, controlling the tap for a river that 3 nations depend on. The state-owned firm Power China formally began work on July 19, 2025, in a location so isolated that the logistics alone represent a monumental challenge. Central to the plan are 4 parallel tunnels, each stretching 20 kilometers, bored directly through a Himalayan mountain. But before any tunnel could be dug or any dam wall poured, the builders first had to solve a more basic problem. How do you get anything into a canyon with no roads at all? The answer came in 2022 with the completion of the Pimlico Highway, which now serves as the single lifeline for the entire project. 40 million tons of cement and millions of tons of steel all have to travel in along this one route, since there is no alternative corridor. From that main highway, engineers have carved out a web of secondary access roads, blasting new spurs directly into the canyon walls, because every construction platform requires its own dedicated route. Crews first drill into the rock face, inspect the geology, then set charges to clear a path forward. In just 4 months, roughly 12 kilometers of fresh roadway have been cut. Given how frequently the Himalayas experience seismic activity, every exposed rock face gets reinforced with bolts immediately, leaving nothing unsecured. As the road network stretches further, 6 new bridges have gone up just to link the first dam site across side canyons. Some locations remain too remote even for this expanding road system, so heavy lift helicopters ferry in equipment that cannot wait for road construction to catch up, particularly precision components and emergency supplies. To cross the main gorge itself, engineers installed a cable car system that reduces an 8-minute crossing to what would otherwise be a 3-hour drive around the canyon. The logistics infrastructure alone has consumed billions of dollars, underscoring a simple truth.
Power lines trace the highway, bringing electricity to wake up the sleeping giants of heavy machinery. Road, then power, then camps, then heavy equipment. A strict sequence that had to unfold perfectly. With access secured, all attention turned to the ultimate adversary, the Yarlung Tsangpo River itself. Surging at 14,000 cubic meters per second, taming this violent water was the next major hurdle. In just 6 weeks, an entire canyon wall was vaporized in 4 explosive seconds. The blast opened a massive new path, preparing to swallow the river's entire flow. Fleets of massive excavators hauled away the debris, shaping the new diversion channel. An upstream cofferdam began to rise, forcefully choking off the river's original path. Built with rockfill and sealed with a dense clay core, it formed a watertight barrier against the torrent. Gradually, the mighty river surrendered, finding its new path through the blasted granite. For the first time in recorded history, the original riverbed slowed, drained, and dried.
The exposed bedrock beneath was remarkably clean and solid, surpassing all engineering expectations.
Every loose fragment of history was aggressively cleared away to expose the perfect foundation.
Foundation cores were drilled and meticulously catalogued, meter by grueling meter.
A massive grout curtain was injected under immense pressure to seal ancient fractures.
Simultaneously, 5 separate dam sites were prepped, transforming the canyon into Earth's largest active construction zone. Meanwhile, beneath the towering Namcha Peak, an even greater invisible battle was beginning. Nearly 7,700 meters of solid granite stood in the way of 4 planned parallel tunnels. To conquer the mountain, engineers brought in the largest tunnel boring machine ever used in Asia.
Weighing 4,000 tons, it took 4 months just to piece this mechanical leviathan together.
Equipped with 240 tungsten carbide discs, it was designed to chew through solid mountain. Once operational, it unleashed its full power against the ancient Himalayan rock. Inside, conditions are brutal, deafeningly loud, blisteringly hot, and 20 kilometers from daylight. Behind the massive cutter head, automated systems slide precast concrete segments into place,
forming perfect supporting rings. One is completed every 40 minutes under optimal conditions.
Each tunnel violently displaces 50,000 cubic meters of granite, repurposed immediately for access roads.
4 colossal machines bore in perfect parallel, hollowing the mountain from 4 directions at once.
At the 8-kilometer mark, the machines struck severely fractured rock and massive groundwater intrusion. After 51 grueling months, the 20-kilometer tunnels were finally punched through the granite. Massive steel penstock pipes were then threaded into the completed concrete arteries. These steel veins are designed to carry roaring water at terrifying speeds of 60 meters per second.
Seismic sensors, bolted every 100 meters, stand guard to provide early warning of ground movement. At the river-facing ends, colossal intake gates were fitted to regulate the massive incoming flow.
Attention pivoted back to the 5 dams, beginning at the steepest gradient for maximum energy potential. Dedicated batching plants feed an endless, continuous pour of concrete down to the valley floor.
Discarding traditional forms, builders use roller-compacted concrete, laying it down in thin, rapid layers.
Heavy vibratory rollers crush the 300-millimeter layers, drastically accelerating the build time.
Intricate cooling pipes run continuously through the structure to battle extreme Himalayan temperature swings.
5 kilometers downstream, a second colossal dam rises in perfect synchronization. A masterfully coordinated schedule ensures all 5 structures reach the heavens together. Alongside each wall, 900-ton spillway gates are installed to handle the most violent monsoon overflows.
In this unforgiving environment, these massive components demand absolute precision on a single attempt.
Work pushes relentlessly through the dark, as the freezing night air naturally cools the fresh concrete.
Every single layer faces ruthless inspection, core sampled to verify ultimate density and strength. Any layer that fails to meet perfection is immediately pulverized and mercilessly repoured.
Finally, the uppermost dam wall topped out, a monumental shield of solid rock and steel. With the wall complete, the diversion gates closed, and the violent river was trapped. The remaining cascades topped out in perfect sequence, locking the entire canyon in concrete. Together, they capture the canyon's brutal 2,000-meter drop, harnessing unimaginable kinetic power.
With the permanent walls sealed, the massive temporary cofferdams were aggressively demolished. Billions of dollars of obsolete structure sank into the newly formed abyss, their purpose fulfilled. Focus now plunged to the base of every cascade, where the true heart of the project awaited. Powerhouses the size of cathedrals were built at the foot of each towering wall. Each station houses 12 colossal turbine pits, measuring 12 meters across.
Cast in Shanghai, these 300-ton spiral casings endured an 18-week cross-country odyssey.
Traveling by rail to Lhasa, then surviving a brutal 500-kilometer road journey to the gorge. Massive cranes lower the steel shells into place, ready to guide the crushing force of the water. Internal wicket gates are installed to regulate the violent flow and control power output. Runner alignment is meticulously verified to within hundredths of a single millimeter. Even the slightest microscopic misalignment could shatter a runner within hours of activation. Beneath each runner, colossal draft tubes are cast to release the spent water safely downstream. All 5 powerhouses drove forward simultaneously, a 24-hour symphony of industrial might. Tail race tunnels prepare to return the water, stripped of its energy, back into the canyon. High-tech switchgear rooms stand ready to manage the terrifying 12,000 megawatts produced per station. Massive step-up transformers sit outside, ready to violently amplify the voltage to 800 kilovolts. In Harbin, the largest Francis-type turbines ever conceived were forged for the project. Weighing 280 tons each, every runner endured a brutal 3-month journey to the canyon. Overhead cranes precisely dropped the massive steel hearts directly into the turbine pits. Above each turbine, massive generator stators are locked into place, ready to capture the spin. Complex stator windings are perfectly connected, sealing the housing for maximum electrical induction. 12 colossal generators dominate a single hall, combining for 12,000 megawatts per site. Just one of these 5 stations easily dwarfs the entire output of the historic Three Gorges Dam. A centralized control room connects the entire nervous system of the canyon, allowing a single control hub to oversee all 60 turbines with absolute precision. Gas-insulated switchgear was chosen, as open-air yards are too hazardous for the Himalayan extremes. Massive transmission towers now pierce the sky, standing like sentinels on the canyon rim. Carrying electricity across 4,000 kilometers of ultra-high voltage lines directly to eastern China. Converter stations in Sichuan intercept the power, switching it back to alternating current. Injecting clean, gravity-fed energy directly into the massive national grid in mere milliseconds.
India closely monitors every single fluctuation, guarding the lifeline of 300 million people.
Engineers insist the output matches the input, borrowing only the elevation, not the water. But this vital river now flows through infrastructure entirely outside downstream control. Bangladesh sits furthest downstream, inheriting whatever changes occur deep in the Himalayas. 5 dams, 4 megatunnels, 60 turbines, and $167 billion. No single river-based power project in human history has ever matched this terrifying scale. For millions living downstream, these mega-power structures represent a river managed without their voice. Yet, it promises to supply hundreds of millions of households without the heavy toll of coal emissions.
The mountain that once stood untouched now holds a raging torrent of energy within its core.
The landscape of the Tibetan Plateau has been permanently, undeniably altered. One of the last untamed rivers on Earth will never return to what it was before.